Alright, welcome to section 5.4. Here we're going to be looking at the sum and difference formulas for both sine and tangent. And so they do have a spot above in this page for us to derive them, but again, they've done that already for us in the book, and you can take a look at that. So remember, cosine of a plus b was cosine, cosine, sine, sine. Since the cosine, cosine, and the sine, sine were the same, we changed the sign in the middle. Notice here it's sine a cosine b, and then it's the exact same thing because where we're getting the difference is right here. So I just remember cosine a plus b is cosine, cosine, sine, sine. Sine a plus b is sine, cosine, cosine, sine, right? And then the same sign right in the middle there. So let me erase that so you can see this a little bit better. So sine a plus b, sine a cosine b plus cosine a sine b. Sine of the first angle, cosine of the second, plus cosine of the first, sine of the second. Pretty nice. So that you have the exact same symbol in between. Same with tangent, and has the exact same symbol up top. Tangent a plus b is tangent of a plus tangent of b, and then always the opposite sign on the bottom, all over 1 minus the product of the two. So tangent a minus b, subtract the two tangents, and then all over 1 plus the product of the two tangents. So I would say it is worth your effort to memorize knowing what you're going to see. So as we go through and look at this next set of problems, what we want to do is keep in mind that there's usually more than one way. So somebody might take advantage of sine and cosine and whether they're even or odd and work the problem that way. I'm going to just model doing it directly, finding a direct path in there, and I hope that's okay. So you can see that they're going to do sines and tangents one right after the other. So they haven't broken it into sections. They just want you to see the problem, I guess. I'm sorry for the hesitation, and then go forward and do. So 5 pi over 12. We need to figure out a way to get 5 pi over 12. So remember my suggestion. We pay attention to the denominator and realize that we have angles like, I'll write them across the top, pi over 6 to work with, pi over 4 to work with, or pi over 3, because we want the exact value. You cannot go to your calculator. You have to go through the square roots and stuff. The calculator will give you a decimal approximation, and that will give you 0 points. There's not a question of you know where the sign button is on your calculator. That's crazy. The question is can you mathematically think and work through problems? So remember what pi over 6 is. It's 2 pi over 12. This would be 3 pi over 12, and this would be 4 pi over 12. Is there any way to get to 5 pi over 12? Yeah, these two added together would give us 5 pi over 12, except I want negative 5 pi over 12. Well, what if we did this? This is the sign of negative pi over 6 minus pi over 4. So minus pi over 6 minus pi over 4. So let's make sure that works. Minus pi over 6 would be negative 2 pi over 12. Minus pi over 4 would be negative 3 pi over 12. Absolutely, that's negative 5 pi over 12. And so we're just using our arithmetic skills from way before we even were in algebra class. Now we're set. So what's this equal to? This is equal to sine of the first angle times cosine of the second angle. Now the second angle is positive pi over 4, right? Because I'm using the minus sign there as a subtraction. And then same different things here. Sine and cosine are different, so I'm going to use the same sign in the middle. And cosine of the first angle, sine of the second angle. And then we're just careful, right? Being careful as we go through here. So what is this? Sine of negative pi over 6. That's a fourth quadrant angle, so that's going to be negative. Pi over 6 is 1/2. Cosine of pi over 4, root 2 over 2. Minus cosine of negative pi over 6. That's a fourth quadrant angle, so cosine's positive, so positive root 3 over 2. And sine of pi over 4, root 2 over 2. So again, if you're not able to say root 3 over 2 really quickly, you need to spend some time there. Negative root 2, right? Negative 1 times root 2 is negative root 2 over 4 minus root 6 all over 4. And so the answer that would be in the back, and the only one to give you full credit, is negative root 2 minus root 6 all over 4. On a test, you'd have to show me all of that. You could not just write the end answer and be done. You could, but you get no points, right? And so there we go with that guy right there. Tangent of negative 7 pi over 12. Let's look at these guys again and say, how can we get 7 pi over 12? Let's readjust. These are our guys. They're picking 12s for a reason. They could pick anything that's a multiple of 6, 4, or 3. So there's other choices, but they tend to like these. These guys give me 7 pi over 12. So what if we considered this as the tangent of negative pi over 4, right? That would give me a negative 3 pi over 12 minus pi over 3. And they could have been in any order. So if you're like, why did you put that first? I was just doing them the way they appeared left to right. Doesn't matter. They absolutely add up to negative 7 pi over 12. So what do we got? We got the tangent of negative pi over 4 minus the tangent of positive pi over 3. Right? I'm just going to stress that again. What you're subtracting away is positive pi over 3. The subtraction signs match. Now I use the subtraction sign up top, so it's 1 plus on the bottom, and always the product of the two down here. So let's talk about tangent of negative pi over 4. That's a fourth quadrant angle, so it's going to be negative. And tangent of pi over 4 is 1. So negative 1 minus tangent of pi over 3, as you know, is root 3. All over 1 plus negative 1 times root 3. So one reason I like this is because you've already figured out what you needed for the bottom on the top. So this is negative 1 minus root 3 all over 1 minus root 3. Okay, those are different from one another, but you can't leave it like that. So you have to rationalize the denominator by multiplying top and bottom by 1 plus root 3, just like you did in Algebra 1 and reinforced in Algebra 2. This is a necessary skill that you developed way back when. And if we do the FOIL, negative 1 times 1 is negative 1 minus root 3. Negative root 3 times 1 is minus root 3. And negative root 3 times root 3 is minus 3. All over 1 minus 3. I know that you know the bottom is a 2 things squared. So what's that equal to? Sorry, running out of room here. So that's equal to negative 4 minus 2 root 3 all over negative 2. They won't leave it like that because you can take negative 2 into both of those and they'll have the answer as 2 plus root 3. And you're finished. 2 plus root 3. Again, you could take advantage of even and oddness of functions and get the negative out of there. I just wanted to show it handling directly. There's always more than one way to do this. Write each function as a single function of x or theta. Great, we know how to do this. Now look what they did. They put cosine back in from the previous section because they're wise. They want to make sure that we have holistic memorization. That we say, oh, cosine, that's the cosine. Opposite sign in the middle, sine. They say, oh, cosine of 30 degrees, root 3 over 2. Sine of 30 degrees, 1/2. And so what will they do? They always write it as a single fraction. So I'll model that. Root 3 cosine theta plus sine theta, and both are over 2. So they're just putting those numerators together with the common denominator, right? Put that over 1 in case that freaked you out. I think we're well beyond that, though, signing up for this class. And then how about this? Sine of 3 pi over 4 minus x. Okay, sine. That's right. That's sine of the first angle times sine of the second. I'm sorry. Times cosine of the second. Apologize. Don't know why I said that. So sine, cosine, since those are different, same sign in the middle. And then cosine of that first angle is how they choose to do it. And sine of the second angle. And so we have sine of 3 pi over 4. 3 pi over 4 is a second quadrant angle, so it's going to be positive. So this is positive root 2 over 2 cosine x. And this is cosine of 3 pi over 4 is going to be a negative. And so that's going to be negative root 2 over 2 sine x. So I got root 2 over 2 cosine x plus root 2 over 2 sine x. They are consistently writing it as a single fraction. So get in the habit of doing that. All over 2. That's it. That's what we're dealing with in order to get to the answers there. So why don't I break this video because there's a bunch more problems to do. There's 1, 2, 3, 4, 5, 6, 7 more problems to do. Actually, why don't we do the next one? Sorry for the hesitation. They want us to find the sine of s plus t and the tangent of s plus t. This time, s is in quadrant 2, t is in quadrant 1. So you know what we're going to need. We're going to need to know some things. We're going to need to know the cotangent and tangent of each one of these guys. So let's go draw some triangles. Let's go get everything we can about s. Where is s? S is over here in the second quadrant. What do we know about s to start out with? That its cosine is negative 15 over 17. If you look at negative 15 squared plus y squared is equal to 17 squared, you're going to get very quickly y squared is equal to 64, and so y is equal to 8. And so this part right here is 8. Let me erase this s that's way over here and just write it out over here. So angle S is right here. So this is all related to S. Now angle T was in quadrant 1. This one I think you can get a lot faster. What do we know about angle T? Its sine is 4/5. That means this adjacent side is 3. I think we remembered that there's a 3, 4, 5 right triangle. I don't know many that remember there's a 15, 8, 17 right triangle, but it is true. There's a 15, 8, 17 right triangle. And so this is angle T over here. So we're going to look to those triangles as we need those different pieces. So sine s plus t. Let's first write out what we need. We need sine s, cosine t. Those are different, so we're going to use the same sign in the middle. Cosine s, sine t. Perfect. We know what that is. Sine s wasn't given to us, but I can go up here and find it. Sine s is 8/17. And it's positive. That makes sense. It's second quadrant. Cosine t. Cosine t was not given to us either. That's 3/5. And I can get that from the triangle above, right? So I'm looking right here and seeing that the adjacent side is 3 over 5. Cosine s totally given to me as negative 15/17. Sine t totally given to me as 4/5. I don't need to look to the triangles if I don't want to. So 17 times 5 is 85. 8 times 3 is 24. And then we're going to have plus negative 15 times 4 is negative 60 all over the same 85. And if I take 24 off of 60, I come down to 36 over 85, and it's negative. Negative 36 over 85. Now, that's what the sine of s plus t is. What's the tangent of s plus t? So I'm going to make that a little bit smaller because if you remember what tangent is, it's the tangent of s plus the tangent of t. That's what we would have hoped it would have been. Unfortunately, it's not just that. We have 1 minus on the bottom. Why minus? Because the top was a plus. And then always the product of the two. Tangent of s. Let's go look at s. It's adjacent. Apologize. It's opposite over adjacent. So it's negative 8/15. And over here, for t, it's 4/3. And so on the bottom, I'm going to have 1 minus negative 8/15 times 4/3. So this one's going to be a little bit more messy. So what do we have here? Let's put these together. Let's see if I can do that a little bit more condensed. So if I make this a 15, then this is going to be 20, and 20 minus 8 is going to give me 16 over 15. Sorry, I don't know why I said 16. 12 over 15 all over 1 minus, and that would be 32 over 45. And so that's 12 fifteenths all over 1 minus 32 over 45. That would be 45 over 45. Oh, it actually is going to be plus, right? Because of the two negatives, so plus. Sorry, I didn't catch that. That was driving you nuts. The negative times a negative is a negative, or sorry, negative times a positive is a negative. Minus a negative would be a positive. So we're going to end up with 77 over 45. So it's just simple addition, right? So we're rewriting one as 44 over 45 over 45, plus 32 is 77 over 45. So now what do we have? That's equal to 12 fifteenths divided by 77 45ths, or times 45 over 77. And it might have driven you nuts that I didn't simplify the 12 fifteenths. You don't really have to if you don't want to. 15 goes into 45 3 times. 3 won't go into 77. 12 has no part that would either. And so we end up with a nice 36 over 77. Now take a look at the last question. So these types of questions should make the exam, where you're given these ones, where you'll find it in every section that's like this, and they're just really good questions. Now the quadrant of S and T should be completely identified, because here's what you know. You know the sine of S plus T was equal to negative 36 over 85, but in particular was negative. The tangent of S plus T was equal to positive 36 over 77. So where is my sine negative but my tangent positive? Right here in quadrant 3. Only quadrant that happens in, and that's the only way you know where that thing ends up without knowing the exact angles in there. So I'm going to stop this video and make a second part to this 5.4 section, and then we'll move forward from there. Okay.